Hello and welcome to Intro to Programming. So in a second, I'm going to have you pause this video. You're probably saying to yourself, why are we pausing the video? We just started. The reason that you're going to pause the video is that I want you to work on an entity relationship diagram. Okay, so that's what we've been doing the last couple of classes. And I want you to sketch out an entity relationship diagram for some sort of retail business. So imagine that this business has multiple locations and that they sell some sort of product. I'll leave that up to you. The product doesn't really matter, just more think about like, okay, this is a place that has multiple stores. The stores can have multiple products. Customers can buy those products and they can buy multiple products and things like that. So pause this video and then sketch it out. And then I'm going to show you one possible setup for what this might look like. But again, don't just keep watching. You need to practice this if you're going to be able to do it on your own for the eventual project. Okay? So with that said, pause the video, come back, and when you come back, I'm going to show you what I have. All right, so let's take a look at what I have. All right, now this probably looks a little chaotic right now. That's fine. Let me talk to you about what we're actually going to be showing here. All right, so I broke it down into 5 tables. And I chose 5 tables because, again, that's the size that your project is going to have to be in this class. Now, I didn't actually worry about the fields or the attributes inside of the tables. I kind of left that up to you. But I'm going to focus on talking through the connections and the keys, all right? Because that's the part that's going to be a little trickier and we've got to get used to. So I started with the stores table. So here's my stores table. And I said, all right, if I'm going to have a store table, I need a store ID. All right. And that store ID is my primary key. I put all my primary keys in blue here to kind of color code it. So this is the unique identifier that lets me tell my stores apart. Now, as far as the fields, there'd probably be things like phone numbers, addresses, and all that other stuff. But I leave that sort of up to you to fill in the details. All right, the other big table that I had was the products table. All right, so here's my products table. And I said, all right, this keeps track of all the different products I sell. So I need a product ID, which is the primary key. And then again, there's all sorts of details that you'd want to have in here. What's the name of the product? What does it cost? What sort of options can you get? But this is my products table. And then I said to myself, all right, well, stores have many products, and each product can be in many stores. So there is a many-to-many relationship between my products and my store because one product can be in many different stores, and each store can have many different products. And as we said on Wednesday, there is actually no such thing as a many-to-many relationship, or at least we can't create a many-to-many relationship in the database. We have to create that relationship through an intermediate or a linking table. All right. So I called my linking table the inventory. All right. And this inventory table basically tells me what product is at what store. So I've got the inventory ID, which is my primary key. And then I have a product ID, which is a foreign key. And it's a foreign key because the product key was actually created here, but then I'm loaning it out to the inventory table, or I'm sending it away to the inventory table. So it's in a foreign table. And the other foreign key is the store ID. All right. So you could think of this as a list of numbers where it's like, okay, store 1 has product 3, and store 1 has product 2, and store 1 has product 5. And there might be another field here that's how many they have of product 3. So this store has 20 of product 3. It has 30 of product 2, and so on and so forth. And you would keep doing that for all of the stores and all of the products. So okay, store 2 also has product 3, but they only have 10 of them. Store 2 has product 4, and they have 5 of them. And it would just keep going like this, where you have these pairs of numbers. All right, these are 2 separate numbers, one that's the store and one that's the product. So this cross references back to my store table, so I know what store that's referring to. This cross references back to my product table, so I know what product it's referring to. And then this just might be a separate field where I keep track of like num in stock. But this serves as the linking table for this many-to-many relationship between stores and products. So again, these 2 keys combined, we can kind of think of them as a compound key, because those 2 numbers give me sort of a unique combination that I can use to keep track of how much product there is in each store in my business or across all of my businesses. So again, there's a many-to-many relationship between stores and products. So I break up that with this inventory table. So one product can have many inventory entries, one store can have many inventory entries, and I sort of fake this many-to-many relationship with this linking table in the middle. All right. So that takes care of my stores, that takes care of my products, that takes care of knowing which products are available in which stores. All right. And again, I'm focusing on the keys here, but there would be other details. So like on this table, you might have something that says like num in stock and things like that. But right now I'm just focusing on the keys. So the other big part of running a business is your customers. So you might have a table that keeps track of your customers. All right. And again, that would need a customer ID. That would be your primary key. And then the sales table is what really sort of joins everything together. All right. Because when a customer buys something, you need to know who the customer was, where they bought it, and what they bought. So it ties together these 3 things. All right. Now, one customer can buy many things. Each product can be bought by many customers, like lots of people might want to buy a certain product. And every store, hopefully, is making lots of sales. Otherwise, it's not going to stay in business long. All right. But each sale only goes back to one store. Each sale only goes back to one customer. Each sale only goes back to one product. So this table is going to have even more ID numbers. All right. It has the sale ID, which is my primary key. So each sale gets a unique number. But then I have 3 foreign keys. I'm going to put down the store ID, the customer ID, and the product ID. So you would say to yourself, all right, that item was bought at store 1. It was item 4, and it was bought by customer 10. And you can go back to those and say, all right, this one's my store. This one's my product. This one's my customer. Now let me go back and look and see which each of those were. All right. So customer 10, that was, Frank, and product 4 was a hammer, and he bought it at the location in Hudson. All right. And then the next one might be like, oh, they bought it at the store in Kinderhook, and they bought a towel because product 3 is a towel, and it was bought by Jane. All right. Because Jane is customer 2. All right, but the sale table, I keep doing that, is going to go back and basically tell us what they bought, who bought it, where they bought it, and all sort of that valuable information that we need. All right. And again, there would be other details there, like maybe price or credit or cash or check or whatever, or how they paid for it. But this sort of gives you the breakdown of how we can sort of keep track of this information using these ID numbers and having these relationships between the different tables in our database. So again, I've got a products table, an inventory table, a stores table, a sales table, and a customers table. All right. You may have came up with other tables. That's totally fine. This is just one example. And again, I focused on making 5 tables because that is the size that's going to be required for your eventual product. Not required, but that's the minimum size that you're going to want for your eventual project. All right, so again, this is just an example of how it could be broken down. It's not the only way it could be broken down, but it hits on a lot of the things we've been talking about. All right, we've got a lot of these one-to-many relationships. All right, we've got primary keys. Anytime we send those keys to another table, we call them foreign keys. And these numbers are going to be what allows us to sort of connect and integrate everything in our database. All right, so hopefully you did this. Hopefully you came up with something that works. And now we're going to move on to sort of the second part of today's lesson. So you should have a database on Google Classroom. I have also emailed you that database because we've been having issues with downloading files from Google Classroom. But either way, you should have it. And when you open it, you should see something. You probably won't see this yet, but you should see something like this. You're just going to open it. There's going to be a gray screen. You've got 5 tables on the left, and there might be a little bar up here that says, like, do you trust this or enable content? You can just hit yes to that, and you're going to want to hit yes to that. Otherwise, you're going to have a hard time doing some of the stuff we do later. All right, so this is a simplified version of the music database that we developed as a class. So if you click on any of these tables, you're going to see I have an album table. All right, and there's an album ID. That's my primary key. There's an album title. There's a release date. There's an album length, which is just being recorded in like seconds. So that would be like 2,731 seconds. And then there's this artist ID, which is a foreign key. All right, this is telling me the number of the artist that produced this album. So if I wanted to know, like, oh, who produced this album, I would have to go to my other table and look up to see who artist ID 4 is. And yes, that's annoying for us as humans, but it works really well for the database and the way the database is set up. So we've got 20 albums in here. We've got all these release dates. We've got lengths. And then we have artists that they correspond to. All right, if we go to the artist table, here we have our artist IDs. We have some artist names. And we have an artist bio, and then their debut year, so the year that they started. And we can see now that these correspond back to those albums. All right, so, Weird Al Yankovic is artist ID 10. So if I go back to that album table, there's artist ID 10. So I now know that these are Weird Al albums. All right, so that's how you can kind of trace these back and forth. I've also got the song table. All right, so this has a song ID. It tells me the song num, which is like the track number, the song name, and the length, which is again in seconds. So, and then finally, I can't believe I didn't mention this, is the album ID. All right, so this is the foreign key that lets us trace it back to an album. So let's say I had this song here and I was like, oh, who sings the song Permanent December? I have no idea. All right, well, Permanent December ties back to album 4. So if I go back to the album, I can see that album 4 is Can't Be Tamed. All right, great. But that album is produced by artist 2. So now if I go to the artist table, I can see, oh, artist 2 is Miley Cyrus. That's embarrassing. I wish I'd picked somebody else. But there you are, Miley Cyrus. That's the artist that I just came up with. Okay, so we can use these numbers to trace information around our database. And again, it's annoying for us to do it, but it's going to be really easy for the database to do it. All right, now we have our user table. All right, so this is our user table, and we have different user IDs here and different user names. So we've got some teachers in our table here and some various usernames here. So here's Mr. Shull. His username is Bossman. And there's Miss Sanchez, and her username is Bosswoman. And then we've got Mr. Staffy, French Rocks. Get it? Because he teaches French and earth science. So French Rocks. Get it? That's good, right? It's so good. Admitted, it's good. So anyways, this is our user table, and we have user IDs. Now, the last table is what we talked about last class, which is a linking table. And I called it the collection table. But what you're going to see is it's basically just a bunch of numbers. All right. It's telling me the user ID, the song ID, and then what that user rated that song. But all of these numbers trace back to the other tables. So if I go way down here, I can be like, oh, okay, user ID 30, which is Mr. Shull, owns song 1, which is So Much Better, which is on album 1, which is self-titled, which is by artist 1, which is Rockapella. So you can see by tracing these numbers, I can find out anything that I want by kind of following the numbers throughout the database and pulling that information together. And that's what the database is going to be able to do really quickly and efficiently. It's basically going to be able to follow those numbers around the database and use them as sort of a path or a guide to connect all of the different information in our database. So these are all our different tables. All right, we've got this collection table that's just basically these pairs of numbers. We've got our user table, a song table, an artist table, and an album table. Now, what I want to do is I want to go to the database tools up top here, and then click on relationships. All right, so I'm going to click on relationships here. All right, and what should pop up is a picture of all of the different tables in our database. All right, so this is a good way to just visually sort of see what's happening. So we've got our artist table. One artist can have many albums. That's the one in the infinity. And then notice that the artist ID, which is our primary key, goes down and becomes a foreign key in the album table. So remember, the primary key always goes from the one side to the many side. And then we have one album can have many songs. So here, this album ID is on the one end, so it goes down and becomes a foreign key in the song side. Now, really, the relationship is between users and songs. One user can own many songs. Each song can be owned by many users. So there's a many-to-many relationship between songs and users. But we can't actually do a many-to relationship. So instead, we create this intermediate or linking table that sort of simulates the many-to-many relationship. So on the picture, it just looks like a one-to-many and another one-to-many. This is really a many-to-many between song and user, and we use this as our linking table. But again, the keys work the same way. The song ID goes from the one to the many, and it comes down here. And the user ID comes from the one to the many and comes down here. And you might notice that this one actually has two keys. It doesn't have its own single key. You can do that. Instead of having a separate collection ID, you can say, hey, user ID by itself isn't unique. All right, I've got lots of the same user in this table. Song ID by itself is not unique. I have lots of song IDs that are exactly the same, but the pair of these are unique. If I look at both of these numbers together, it's always going to be a unique combination. There would never be a second 1-3 in this table because the user already owns the song. We'd never put it in again. There'd never be a second 4-12 in this table because, again, it's a unique combination. So we can actually get away from having to do a separate collection ID if we want and just use these two together as what's called the primary, the compound key. So these two together as a compound key, again, because we're sticking them together like you stick together a compound word, would be a unique identifier in this table. All right, so that's just kind of a walk through this database. What we're really going to focus on today is SQL and learning how to write code to pull information out of the database. Because we've got these tables, but all the tables are sort of separated and all the information is presented in one big go. We want to be able to request specific things from the database. The same way that when you're on a website and you search for a product or click through IMDb, it's only giving you specific information. So that's our next sort of step in this whole process is now that we have a database, how do we pull specific information that we want out of it? All right. And that's where SQL, which stands for Structured Query Language, is going to come into play. All right. It's going to teach us how we can pull information out of here. So the first thing I'm going to do is I'm just going to close out everything that we've got open here. So you can either close them one by clicking on them and clicking on the X. You can right click on them and choose close, or you can right click on one of them and choose close all. If it asks you to save the relationship, you can. It's just because we drag the tables around. We didn't change anything. So to create a query in Access, or again, a query is another name for a search. So to search through our database and pull out information, we're going to go to Create. We're going to go to Query Design. Now, Access has like a whole tool built into it for designing queries. We're not going to use that tool. All right. We're going to learn how to write the code from scratch because, again, if you're building any sort of website or web database, you have to write the code from scratch. There's not like a tool in all of those databases. A lot of times you're just writing the code from scratch. So we're not going to use the tool that's built into Access. This is for people that don't know anything about SQL. And it tries to make it easier for them. But we're going to learn about SQL, so we're not going to need this. So when this pops up, you can just click Close. And then what you're going to want to do is you're going to want to go to SQL View. So there are a few ways you can do that. There's either a big SQL View button over here on the left. You can right-click on this and go to SQL View. Or there's also a little SQL down here at the bottom right that will bring you over to SQL View. All right, but whichever way you do it, it should bring you to this screen where you've got just sort of a blank screen and the word select. So we can start just by deleting that. Now, what I'm going to do in this video is there's not a great way to zoom in this program. So I'm actually going to write the SQL in another document so that it's larger and you can see it more easily. And then I'll just keep copying and pasting it over here. Just realize you don't need to be doing that. I'm just doing it so it's easier for you to sort of read. All right. So let's see here. Let me open a Google Doc. All right. So here we have a Google Doc. And again, I'm just going to be copying and pasting from this over to Access so that it's easier to see. So when we are pulling information out, there are two keywords that are going to be part of every single code that we write. All right. The first keyword is select. All right. And I'm going to write that in all caps. Now, the code will work even if you don't write it in all caps, but this is sort of the standard. This is how programmers do it to make the keywords stand out. It's kind of like you can think of it as proper grammar or proper etiquette when you're writing code. So I'm going to write select in all caps so that it stands out and is easy to see. Let me see if I can make this even a little bigger here. Following the other keyword, and I'm going to hit enter here, is from. All right, so these are the two words that are going to be part of any query that you write that pulls information out of the database. So what follows select is the different columns in your database that you want to view. So for example, if we're pulling information out of our album table, I might want things like album title, release date. Maybe I just want those two things. All right. Maybe I just want album title. Now, I'm putting the column names in all lowercase. Again, SQL doesn't really care whether you capitalize or don't capitalize, but this is sort of the convention. All right. We put the keywords in all uppercase. We put the database sections like in all lowercase. So I'm going to do album title. I'm going to do a comma because I want to have a second one. And then I'm going to type release date. All right. I don't have any spaces between those because if you look in my database, and I look at the column heading, there's no space there. It's release date, all one word. Yes, these have a capital R and capital D, but again, when we're writing the code, the convention is to keep it all lowercase. All right, so I've got select album title, comma, release date from the album table. All right, so this would be about as basic of a query as I could write. So I'm going to take this, I'm going to copy it over. I'm going to go to that query window and I'm going to paste it. Now, once I have my query there, if I right click here, I can go to datasheet view and that will run it. I can go to the view button and go to datasheet view and that will run it. Or when you're clicked on the query, you should see that there's a design tab here. From this design tab, I can also click run. All right, so there's lots of ways that I can get to see my results. But what you're going to see is you're going to get a portion of the table, but only the portion that you asked for. So this is coming from the album table, but it's only giving me the album title and it's only giving me the release date. All right, so it's cutting out all of that information and only giving me specifically what I asked for. All right, so what are some other things that we can do with a query? Because by itself, that's not super useful. All right, another thing we can do is we can have the database organize things for us. All right, so I can say order by, and order by are two separate words, so there is a space there. And then I can tell it which field I want it to order by. So I could say order by album title. All right, and if I add this line to my code, let me bring it back over here. So to get back to SQL view, I can right click and choose SQL view, or I can click on that button up there. But I'm going to add this to my code. So now it says order by album title. And when I run this, all right, you're going to see that now it's in alphabetical order by album title. All right, so it starts at B, goes down to T, and it's in alphabetical order. So you can see that this is the sort of thing that's happening when you sort your search results. So if you remember, let's go back. I'm just going to go to Amazon really quickly. All right, let's say that I searched for a Halloween costume. All right, I get my Halloween costumes here. I can sort by featured, price low to high, price high to low, average customer review, newest reliables. When I choose one of these, what that's really doing is changing the order by command inside of the SQL that's getting submitted to the database. So every time I switch this, it's generating a new SQL query that uses the appropriate order by command to get me the results in the order that I asked for. All right, so again, as we learn about this, it's going to give you a better appreciation for how the sites you interact with actually work behind the scenes. All right, so we've got our order by. Now with order by, too many tabs to keep track of. With order by, the default is what's called ascending. All right, that's why it went A to Z. Now, you don't have to specify ascending if that's what you want, but if you want your code to be more readable, you can do ASC, which stands for ascending. That won't cause any problems, and it just makes it very clear that you want it ordered ascending A to Z. Right? If you wanted to go Z to Y, reverse alphabetical, that is DESC for descending. All right, and if I add that DESC to my code, so let me go back to SQL view and add DESC and hit run, you're going to see that now the results are in reverse alphabetical order. I'm starting with T at the top. I'm starting with going down to B at the bottom. And again, that's the sort of thing that's getting changed when I say, oh, sort from price high to low or sort from price low to high. It's changing that order by command, and it's either flipping it from ascending to descending or vice versa. All right. Now, the other big word that we're going to focus on today is where. All right, so most queries actually have all of these. All right, they have a select, a from, a where, and maybe an order by, probably an order by, but not necessarily. All right, now the order of these is significant. All right, the order of these does matter. Select has to come first, from has to come second, where comes third, and then order by closes out the query. Now, what do I want to say about this? As far as the where goes, this is where we can start limiting the results that we get back. Because right now, when we run this, we're just getting back everything. And we might not want to get back everything. All right. Usually, when somebody searches, they're only looking for specific things. So, what I can do is I can specify what I want back. So I could say where album title equals, and then because I'm dealing with text here, I have to put the text inside of quotations. So I could say where album title equals red. All right, and I'm just picking that because I saw it and it was short and easy. All right, but this allows me to start limiting the results that I get back. So I can take this. Let me take this whole query. I'm going to bring it back here. I'm going to go back to SQL view and paste it in. And when I run this, I'm getting enter parameter value red. All right, I have an error somewhere in my code, so let's figure out where that error is. This is good. You can see that sometimes I make errors as well. All right, where is this error? Let me pause this video for a second and find it. All right, good news. The error was just the copying and pasting. The quotation marks that Google Docs uses are different than the quotation marks when you're typing directly into this. So if you're like, hey, mine worked, I don't know why his didn't work. It's because the quotation marks that I copy and pasted in are different than the quotation marks that get used inside of here. So the code was fine. It was just the copying and pasting that was the problem. So once I have this, if I hit run, you'll notice it's only giving me back one result. If there had been multiple albums that had the name red, I would have gotten them all back. But because there's only one in this database, it's giving me back the numbers, just the one value red. Now, we don't just have to do equals. Let's say I wanted to do it by release date. All right. Instead of saying where album title, I could say where release date. And I don't just have to use equals. I can use things like greater than. I could be like where the release date is greater than. Now, text has to be inside of quotes. If you're using a date, like a full date, that has to be inside of the pound sign. So I could say like, oh, where the release date is greater than 1/1/2000. All right, so when the release date is after the year 2000, order the album title by descending. All right, so again, I can start to use other symbols in here. I can use less than, greater than. If you want greater than or equal to, you just write them right next to each other. So a greater than sign and then an equal sign right next to each other. You know, this would, whoops, not that direction. This would be less than or equal to. So you can do equals to, less than, greater than, less than or equal to, greater than or equal to. But those are the main things that we're going to use in something like this. All right. So let me take this right here and say, paste it in here, and hopefully there's no weird pasting problems again. And then if I run it, all right, these are all the albums that are less than or equal to the year 2000. All right, if I go back and change it to greater than or equal to, this would be all the albums that are greater than or equal to 2000. And again, they're ordered by album title because that's what I stated in my order by statement. But I can use this to sort of further limit the results that I get back. All right, and I can go even further than that. Let me look at the album table again. What other fields does it have? Album length. All right, so let me add that to my SQL. So I'm going to say I want album title, release date, and album length. If you want to have multiple parts to your where, all right, we combine those with either the word or the word and, just like we saw in Google Sheets. All right. If we want both things to be true, we'd use the word and. If we only care if one of them is true, we would use the word or. But let's say I want something else to be true, and I could say and album length is greater than, let's say, 3,000. All right. Now notice when I'm typing in a number, I don't use quotes. I don't use pound signs. I just type in the number. So text gets quotes around it. Dates get pound signs around it. And straight numbers don't need anything. So album length greater than 3,000. That's fine. So I can take this whole query, select album title, release date, album length from album, where release date is less than or equal to this, and album length is greater than this. I can take all of that. Let me copy it and then bring it over. So I'll go back to SQL view. Oops. And if I run that, you'll see that only actually one album meets those qualifications. So I only have one album that's longer than 3,000 seconds that has a release date that's less than or equal to 2,000. All right, if I changed it to greater than or equal to, let's see if we get back any more results. Right, yeah, if greater than or equal to, then I get back more results. All right, so if I change it to greater than or equal to 2,000, I get back more results. But I can have multiple sort of conditions in my where statement. And again, if we go back to Amazon for a second, when you search for something, that would be one where statement. And then you see there's these different things I can check. So if I click Amazon Prime, what that's doing is it's modifying the where statement. It's saying where, the search term is Halloween costume and Prime equals yes. And free shipping equals yes. And whatever, and it has to be the brand Morph, whatever the heck that is. So all of these things are just SQL that are being modified to return different information from the database. Now, a couple other things I want to show you, and then you're going to practice some of this SQL on your own. First things first, the easiest one is if you ever want all of the columns in a table, instead of typing them out one by one, you can just say select star from album, and that will automatically give you every single column that exists inside of that table. So if I go back up here and repaste this, if I want every single column, I can just say select star. I can run that, and you'll see that it gives me album ID, it gives me album title, it gives me release date, it gives me album length, it gives me artist ID. It gives me every column in the table without having to ask for each one individually. All right, so that's pretty useful. Another word that's useful is when you're doing ranges. All right, so there's two ways to do a range. Let's say I wanted release dates that were greater than or equal to greater than or equal to 2,000, but I wanted them to be less than like 2005. All right, one way I can do that is I can say and release date is greater than or equal to 1/1/2000, and release date is less than or equal to 1/1/2005. All right, this would totally work. All right, it would say give me all the dates that are greater than 1/1/2000 and less than 2005. All right, and if I paste this in, it will work. All right, there's no reason you can't write the code that way. It gave me back those two results. Great. All right, ranges are so common that there's another word built into SQL so that you as the programmer don't have to type out as much. All right, instead of having to do this greater than or equal to and less than or equal to, where I have to type out release date twice and all this other stuff, I can use the word between. And I can say where release date between 1/1/2000 and 1/1/2005. All right, and this effectively does the same exact thing. It just trades out the two less than and greater thans and the ands and the duplication with just this word between, where it's where release date between 1/1/2000 and 1/1/2005. And you're going to see that I'm going to get back the same results. All right, so if I go to SQL view and paste this in using the word between instead, it's going to give me back those same two results. So this is a word that comes in handy when doing ranges because it simplifies the code. And it's not just for dates. You know, if I said album length between, you know, just put in a number between 2000 and 2,900, 29,000, that will work as well. All right, so it doesn't just have to be dates. It can work with numbers as well. Maybe I'll switch this over to ascending just to mix things up. But this word between can be used anytime you're trying to do a range between two things. You don't have to use it, all right? You can just use and do the duplication there, but it does simplify your code a little bit instead of having to repeat the same thing over and over and over again. All right, so this is sort of your introduction to SQL. All right, what you're going to do now is you're going to practice some of this on your own. You're not going to finish it today, so don't think that you have to finish it today. Just work until class time is over, and then you'll have more time to work on it next class. But there's going to be a sheet that basically walks you through what you need to do. So let me bring up that sheet really quickly. I'm going to bring it up in here. All right, so what this sheet is going to do is it's going to tell you what it wants from the database. So, for example, the first one says, write a query that will list all the album names and their lengths. So you're going to type in here, well, you're going to type in the database and say, all right, let me try to figure this out. Let me see if I can get it to work. Once you get it to work, you're going to copy and paste it into this document. All right, the second one says, write a query that will list all the song names, their song number, and their length. You're going to have to go into the database. You're going to have to search for it and write the query, and then you're going to paste it in here. Now, a couple of things that I'll warn you about. I would have this database relationship diagram up while you're doing this. So again, it's in database tools, relationships, because it's an easy way to see all of the different things that are in the database. So you can see like, oh, artist is artist name, artist bio, debut year, album is this, 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 and this, song is this, 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 and this, and it just gives you everything in one view. So this is a helpful tool to have open when you're trying to write these queries because it gives you all the table names, which you use in the from part of your query, and it gives you all of the column names that you use in the select part of your query. All right, so this is a helpful diagram to have open. The other thing I will warn you about, because you will probably get this error at some point. If you misspell something, so let's say I'm spelling album title and I forget the M and I just type album title from the album table. When I try to run this, you are going to get this little box that pops up that says enter parameter value for album title. What that's basically saying is, hey, I couldn't find album title, so just tell me what you want to put there. All right. The reason it can't find it is because you spelled it wrong. All right. So if you get an error like this, it's probably because you spelled something wrong and you need to go back and check your spelling. All right. There are other errors that might pop up. Those we'll just kind of deal with on a case-by-case basis. But this is the most common error that I see is kids accidentally misspelling a word and then this pops up. Another thing might be if you use the wrong table. So if I try to search for album title in the song table, right, this same thing is going to pop up. This time I spelled it right. Album title is spelled correctly, but I searched for it in the wrong place. So it's saying, hey, I can't find album title in the song table. So it could mean that you spelled it wrong, but it could also mean that you're looking for it in the wrong table. Other errors that sometimes pop up. So if you forget your quotes, so if I say where album title equals red and I forget my quotes, that will also cause problems. Whoa, that just caused it to crash. That usually doesn't happen. But things like that can cause problems, like if you forget quotes when you need quotes. So you're just going to have to kind of go through them, try your best. And then, whatever ones you don't get, just make sure you send me an email. But you don't have to finish this. Get as much done as you can, and then call it quits, and we'll pick it back up Tuesday of next week. All right. So I hope this was useful. Have a great day, and I will see you when I see you.